Okay, in this video we're talking about measurements and being accurate and being precise with our measurements. We're also going to talk about significant figures or significant digits. Sometimes they're called sig figs, whatever you want to call them. In this slide you can see that we have a sniper here, and as a sniper you want to be both accurate and precise. Accuracy refers to truth. In other words, how close to the correct accepted answer you are. That deals with accuracy. Precision refers to repeatability, so how close you can get to the same answer multiple times. If we look at these targets down here, we can see on this one our shots are pretty close to the center, so we would say that these holes are pretty accurate. If we looked at this one over here, we could see that this one, they're all pretty close together, so it's more precise because it kind of has that repeated pattern here. This one would not be as accurate, but it would be more precise. So as a sniper, you want to be both of those things. You want to be accurate, close to the middle, and you also want to have some of that repeatability, so you want to always get those shots right toward the center. And with significant figures, we talked about that in class. It kind of allows us to know exactly how precise or how accurate we're going to be with our measurements. Okay, so what digits are going to be significant? So we have a couple rules that we have to go by. The first one is all non-zeros are significant. So just to kind of give you an example here, if we have, say, the number 32.8, how many, so these are all non-zeros, so this one's going to be significant, this one's going to be significant, and this one's going to be significant. So how many significant figures do they have? Would obviously be 3. Another one, so if we had 12.52, so in this case, now we have 4 numbers that are all non-zeros, so we have 4 significant figures in this case. So that's pretty simple. The next rule is final zeros after the decimal point are going to be significant. So just to kind of show you another example of these, so if we had 2.0, so we have 2, which is a non-zero, so it is significant. We have a 0 after the decimal point, so it would also be significant. So we have 2 significant digits in that case. Another one, if we have, say, 28.40, now we have 1, 2, 3, 4, so we'd have 4 significant digits in this case. The next rule, so I kind of change it around. I kind of like to call it sandwiched zeros. So if they're in between non-zeros, then they are also significant. Examples of this one, so if we had, let's see, if we had 208, so we have 2 and 8 that are non-zeros. Right here in the middle, we have a sandwich zero, so it is also significant. So we would have 3 in this case, 3 significant digits for that number. Another one, just to kind of use all these rules real quick, if we had, let's see, 12.090, so if we looked at all our rules, we have non-zero, 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 those are all significant. Final zeros after, or actually if we looked at the final zeros after the decimal point, so this would be the final 0. And then we have sandwich zeros, so this one would be, so we would have 5 significant digits in this case. Okay, the last one is all numbers in scientific notation. So whenever we're in science class, whenever we're writing really big numbers, so say we have this number here, and usually big numbers like this we're going to write in scientific notation. So if we took the decimal and we moved it back, to right here, and we wrote it in scientific notation. So that would be 4.8 times 10 to the 6th place because we moved it back. So how many significant digits would that have? It would have 2 significant digits in that case. Because all these zeros right here are not significant in that case. So what digits are not significant? The only digits that are not significant are placeholder numbers. So some people get confused with this a little bit. I'm going to kind of give you guys some examples here. So if we have 230, in this case, this one is significant, this one is significant. This number, however, is not significant. It's just a placeholder. So it's just pushing this 2 and this 3 one digit away right here. So that one is not significant. On the other hand, if you have a number like 0.00069, how many significant digits would you have? You'd only have 1, 2. This 0, this 0, this one, and this one are again just placeholders. They're just pushing these numbers out away from the decimal point. Or there are some other rules. Whenever we're multiplying or dividing, so we're calculating things out in a problem, there's kind of a rule that we go by here. So the number of significant digits in an answer should equal to the least number of significant digits in any of the numbers being multiplied or divided. So what does that mean exactly? So if I give you guys an example here of, let's see, 26.4 times 120. What does that equal to? So if I did that in the calculator, well, actually first let's see how many significant digits we have in both these that we're multiplying. So in this one we have 1, 2, 3 significant digits. In this one we have 1, 2. Again, this one is just going to be a placeholder. So we would only have 2 significant digits here. So in this case, since the number of significant digits should be equal to the least number of significant digits in any of the numbers being multiplied. So these are the numbers we're being multiplied. The one with the least amount of significant digits, that's how many significant digits we should have in our answer. So in this case, we should only have 2. So if we calculated this out, it should come to 31,600. So this should be our answer, but we can only have 2 digits here. 2 significant digits here. So this one we're actually going to have to round to 3,200 for our answer. So because we can't have these, now we have 2 significant digits. These are just placeholders, they're not significant digits. So that would be our answer actually. Okay, if we were dividing, so let's do one with just division real quick, an example. So if we had 19 divided by 3, and let's see how many significant digits. In this one we have 2 significant digits, this one only has 1 significant digit. So in this case we would get the 6.333, and it would just keep going on forever. But since we only have 1 significant digit in one of our numbers being divided, then we can only have 1 significant digit in our answer. So this should be rounded to 6, and that would be our answer. So in a lot of ways, significant digits kind of makes your job a little bit easier. You don't have to write all these numbers out. Okay, addition and subtraction. The rule for addition and subtraction, the number of decimal places, so we're talking about decimal places now, not significant figures, should equal to the least number of decimal points in any number being added or subtracted. So if we had an example of 13, so we have no decimal places past it, plus 1.6. So we have none here, we have 1 here. So we should really have no decimal places in our answer. If we added those, we would get 14.6. But we can't have any decimal places there in this one because that's the least number here, 0. So we should actually round that Since we have 14.6, we'd round that up to 15, and that would be your answer for addition and subtraction. Okay, so just to kind of do an example here, you guys are going to do the example anyway. Again, you guys can go ahead and do this, and you're going to put the answer to this question, so 20.1 meters times 3.6 meters. Put that in the little space down below the video for the answer. Again, start out, figure out how many significant figures you have in each one. The least amount of significant figures is how many significant figures your answer should have. So try that, and we'll talk more about it in class. Hopefully that was helpful.